Hi everyone, for this lesson we are going to be discussing rational numbers, and our objective is to extend previous knowledge of sets and subsets using a visual representation to describe relationships between sets and rational numbers. So going back to last year, there were three terms that were covered with you. You had your whole numbers, your integers, and your rational numbers. So we're going to continue with these three, but also add on some additional parts. So before we get to that, let's review these three terms. The first one is rational numbers. A rational number can be any number expressed as a ratio, and remember, a ratio is just another word for fraction. And a rational number can also be a terminating decimal or a repeating decimal. And rational numbers are also integers, whole numbers, or natural numbers. So what is a terminating decimal? Well, remember, a terminating decimal is a decimal that stops. It comes to an end. For example, here you have 3 out of 100. When this was converted to decimal form, it gave you 0.03. The decimal stopped in the hundreds place, making it a terminating decimal. In our second example, 1/8 is equal to 0.125. Notice how this time the decimal stopped in the thousands place, but it still came to an end, so this is why both of these would be classified as terminating decimals. Another way to think about it is the word terminar. Terminar means to stop or to end. Now, what is a repeating decimal? A repeating decimal is a decimal that repeats a pattern over and over and over. Sometimes, like you notice here on this first example, you only have one number that's being repeated, because 1/3 is equal to 0.3333 and so on. So I could just write it out as 0.3 bar. On your second example, 7/11 is equal to 0.6363 and so on. So notice how you have two numbers repeating. And then the last example I wanted to share with you was 1/7, where you have 142857, 142857. So this time you have 6 numbers repeating. What I'm trying to get you to understand from this is that it doesn't matter how many numbers it is that are going to be repeating, as long as it's those same numbers over and over and over. Now, what are integers? Well, integers are whole numbers and their opposites. One thing that integers cannot have are decimals. So when you think of integers, I like to also think of a standard number line, because notice how you have all your positive integers, you have 0, and then you have the opposite of positive to be the negative. And then lastly, what are whole numbers? Remember, a whole number is a number without a remainder that represents whole things. This time though, a whole number cannot be negative and it cannot have a decimal. So whole numbers start at 0 and continue on. So similar to integers, except notice how it's only going to be your positive numbers, not the negative. Now, notice how I have added on an additional circle to our Venn diagram. We've already discussed rational numbers, integers, and whole numbers. But in 7th grade, we're now going to add on natural numbers. And one thing that I like to relate this to is where we live. Your house is considered natural numbers, and your house is within the Edinburgh city limits, and then Edinburgh is within Texas, and Texas is inside of the United States. Hence, natural numbers are going to be whole numbers. Whole numbers will be integers, and integers will be rational. Notice how I went from the inside out, except I'm not always going to be able to go from the outside in. Because if it's a rational number, does that mean it's going to be a whole number all the time? Not necessarily. It can, but not all the time, because not all of the United States is inside of Edinburgh. So, what is a natural number? Well, similar to whole numbers, natural numbers cannot be negative, nor can they not have a decimal. But notice here in this Venn diagram that I included with just natural and whole, the main difference is the 0. Whole numbers start at 0, but natural numbers start at 1. Why? Because natural numbers are called your counting numbers. And what number do you use when you start counting? Well, the number 1. Then 2, then 3, then 4, then 5, then so on. So now that we reviewed our 4 terms, let's go ahead and do some practice problems. The first one is asking us to record each value in the correct location on the diagram. The first value is -2/5. Notice how it's a fraction, and it's already simplified because both 2 and 5 are prime, so I know that I can't simplify it anymore. Natural numbers cannot have a remainder. Whole numbers cannot have a remainder. Integers cannot have a remainder. The only one that can have a remainder, and it can be in fraction form, is your rational number. So I'm going to put -2/5 in the rational numbers area. Our next number is 0. Remember, natural numbers are your counting numbers. So when we start counting, we start at 1, not 0. So I know that 0 is going to go under whole numbers. Now let's go on to -13. Well, both natural and whole numbers cannot have a negative, but integers can. And notice how there's no remainder, just the 13 and the negative sign, so I know it goes under integers. +5. When counting, we do use the number 5, so that lets me know it's a natural number. Now we have 0.3 bar. Remember, when you see this type of decimal, the bar lets you know that the 3 is going to be repeating over and over and over. Hence, why it's called a repeating decimal. So that I'm going to put under rational numbers. And then lastly, -4/2. One would think when they see this value that it's a fraction, so it's going to go under rational numbers. But notice how this is an improper fraction. So before I can classify where it goes, I need to first simplify it. I'm going to keep it negative, but I'm going to divide 4 by 2. And 4 divided by 2 gives me 2, and I keep my negative sign. So now going back to your Venn diagram, remember natural numbers and whole numbers cannot be negative, but integers can, just as long as they don't have a remainder. So -4/2 will go under integers. For our second example, it's asking which of the following statements is not true. Answer choice F, all whole numbers are rational numbers. Answer choice G, all integers are rational numbers. Answer choice H, all integers are whole numbers. Or answer choice J, all counting numbers are whole numbers. So notice off to the right-hand side, I've added in our Venn diagram again. Why? Because I want to, again, relate back to your house, Edinburgh, Texas, and the United States. So all of the rational, I'm going to put USA above them. Then I'm going to go on to integers. I'm going to put Texas. Then I'm going to go on to whole numbers. and put Edinburgh. And remember, counting numbers is the same thing as me saying natural numbers, which is your house. So now let's relate this to real life. For answer choice F, all of Edinburgh is inside of the United States. Well, that is true. Answer choice G, all of Texas is inside the United States. That is true. Answer choice H, all of Texas is inside of Edinburgh. That is not true. And then answer choice J, all of your house is within inside of Edinburgh. That is true. So notice how there is 3 answers that are true and 1 that is not. Why is that? Because this question is asking for which one is not true. So this would let me know that answer choice H would be my answer.